So this is a warm-up. We're doing problem number 30 from 9.1 before we start lesson 9.2. All right, get my cursor going. Okay, so this question says find the distance between these 2 points. So we go to 30. Remember, this is 1 radius, so this is 2. 120 is over here. We go out 5. 1, 2, 3, 4, 5. Yep, right off the end of the graph, right? Okay. So the idea I taught you yesterday was if this radius is 2 and this radius is 5, and we want to find the distance from here to here, yep, that's a straight line. We can use law of cosines if we can find this angle in between here. Well, if it went from 30 degrees around to 120, this is 90. Okay, do we really need law of cosines if that's a 90? We'd use what? Pythagorean theorem. But normally, you would need law of cosines, which is 2 squared plus 5 squared minus 2 that comes with the formula, and then the 2 and the 5 that were the distances, cosine of the angle in between. Okay, it's written on your sheet as the distance is, let me guess, r radius 1 squared plus radius 2 squared minus 2, radius 1 times radius 2 times the cosine of the difference in the angles. How did I do? Because it's the same thing, okay? The same thing. But this is off the reference sheet. What's the other one you had to do? 32. What is 32? Does anybody have the points written down? Thank you. Michael? Okay. It's harder when there's a negative because you have to be really careful. I usually just rename the point if I just want to be lazy. So 645 would be in here at the 45 line. Can I pretend to count these by 2? 2, 4, 6. So I'm going to call that 645. And the 300 line is over here, but it says back up 3. So which line am I really on? 120. The 120 line. And I'm out 3, which I'm going to put at 1.5 because I'm using a half scale. So this is 3, this is 6. I changed this point to 3, 120. So what is the angle in between them this time? 120 minus 45 is 75, right? Michael said it right? So then to find the distance between them, I can just do 3 squared plus 6 squared minus 2 times 3 times 6 times the cosine of 75. Then I have to remember to square root that all to find the distance. Or I can type it in this formula. And I can use this formula with the negative 3 and the 300. You just have to be careful. Better? Okay. Today, we're going to talk about 9.2. So you all have out worksheet 6 and worksheet 10. Worksheet 6 and worksheet 10. Because worksheet 10 I threw on the back as a reference sheet, kind of. Do you see all the cool stuff on the front of 10? That's what we're doing today. Okay. So you are going to have this on the quiz, but you're going to be able to just type them in your calculator, okay? So you just have to know how to do that. Look what I found to show you. These are all things done with polar graphs. Which is your favorite? I like this guy, or this one. Okay, all I did, guys, was I Googled polar graph paper, and I looked at all the cool things that were on here. Ooh, look at this. I don't think that's polar graph paper. Ooh, those are nice. Yeah, I don't think. Okay, here's polar graph paper. All right. So, back to the lesson here. Yep, not sure why that's there. All right, we're going to do one by hand. Whew. Okay, stretch. This is a struggle. Okay, it says graph the following image, and this is the equation, guys. 1 plus 2 times the sine of the angle, okay? Well, to save us time and energy, I plugged them all into the calculator and got decimals. I just want to show you how this would go if you were graphing it by hand one time, okay? So you would start at the pole with a radius of 1. So 0 degrees of rotation, radius of 1. Put your first dot there. Okay, did that one. Now it says go around to pi over 6 and go out to a radius of 2, which is here. Pi over 4 would be this guy. Go out to 2.4, somewhere in here. Now this is going to be a smooth curve as we go. Okay. Then it says pi over 3. We're going to go out a little further to 2.7, still not to 3. And then at pi over 2, we're finally to 3. Okay, so yours look sort of like that, probably better than mine. Okay, now as we go around to 2 pi over 3, we go back to 2.7. And then at 3 pi over 4, which would be here, we're down to 2.4. And at 5 pi over 6, we're back to 2. And at pi, we're back to 1. It's like a circle so far, yes? Yours looking kind of like a circle? But we actually learned how to draw a really easy circle yesterday. Can anybody refresh my memory about that? Yeah, like r equals 4 would be a circle of radius 4, right? But that's centered right at the center, by the way. All right. 7 pi over 6, 0. So at 7 pi over 6, we're going to go back to the pole. Then it says, keep going around to 5 pi over 4. That's this guy, right? And we're supposed to be at negative 0.4. What does that mean? Means I got to back up this way, right? Somewhere over here. It's supposed to actually be less than... move. Covering up things I need. Please move this magical... All right, anyway. I was supposed to be at 0.4, which is like here. Okay, then it says 4 pi over 3, which is this line. I'm supposed to back up a little further, closer to 1, so here, maybe. Then 3 pi over 2, back up to negative 1. So that's the same as what ordered pair? Pi over 2, positive 1. Okay, keep going around to 5 pi over 3, which is this line right here, except I'm supposed to back up negative 0.7 again. And then 7 pi over 4, which would be this. I'm supposed to back up 0.4. And then I'm supposed to be back to the pole. And then at 2 pi, I'm back out here to 1. Okay. Anybody get something looks kind of like that? Like a circle with a loop in the middle? Okay. Are we good? Do you want to do these by hand for the rest of your life? Not so fun, huh? Okay, what we drew is called a limaçon. Okay, it's a French word. I'm probably pronouncing it wrong. But you ever cut open a lima bean or see a lima bean and it kind of has this lighter shade right here? That's what it reminds me of. Limaçon, lima bean, I don't know. Okay. We're going to do this one on the calculator. Ready? Okay. So the first thing I need you to do is go to mode. I need everybody to make sure they do this or this isn't going to go well at all, okay? Go to mode, put your calculator in radians, and then polar. We're over to the third one. Next week, we're going to do sequences. Okay, we got the third one over? Okay. Now we're going to go to y equals. Make sure you don't have a plot on like I do. And now it says r. Okay, so we can type this equation in. 2 cosine 2 theta. We can't use x. Well, we could, but what happens when we hit that x button this time? It says theta, right? Because remember what I told you? Those things across there are based on the mode we're in, right? X was for function mode, T was for parametric mode, theta is now that we're in polar mode. Okay, and the 2 and the theta are together in there, so we could close the parenthesis if we wanted. Okay, this is not going to go well until we set up a window. Now, just like in parametrics, the calculator is literally calculating values. Okay, so we're going to put in 0 to 2 pi, 0, enter, 2 pi, enter, which changes it to a decimal. We're going to leave our step 0.1. If we were in degrees, what would we change the min and max to? 0 to 360. Now, if you're counting from 0 to 6 by tenths, that's like 60 iterations or 60 different points it's going to find and connect. If you went 0 to 360 by 0.1, that'd be 3,600 points it's going to try to connect. Okay, so it would take it a really long time to do. I'm just telling you what's going on here. This step is how often it's calculated. So we're going to leave it this. All right, our x min and max, I'm going to do -5 to 5 by 1s and -5 to 5 by 1s. And then I think in a minute here I'm going to want to do a zoom square, which will make it look better, but I'm just going to graph it. Oh, did anybody get that? Okay, then again, now that you've seen that it works, if you do a zoom square, it'll square it up and make it look like it's supposed to in terms of the symmetry. Whose isn't working? So far, arrow down and not in radians. So if someone else is having trouble, how we doing? Okay. All right. Now we're going to explore what else can happen. I don't know how to make the teddy bear. Okay. This type of curve is called a rose. Okay. If we go back here, there was a 2 out front here, right? I think, oh, wait. Back to, yeah, is that the one we're doing right now? Yeah, we just did it on the calculator, right? Oh, wake up, I'm all right. So we wound up with each petal was 2 long. Oh, that's not very good. Is anybody not getting it to work still? Okay, mine is terribly messy and icky. But we should trace just to see what happens. Now, something weird is happening when we trace. It does show that it's out to 2 here, okay? But we are currently in XY. Do you see that down there? It's giving us XY ordered pairs. If we wanted our theta, everybody watching, you could go second zoom, and up here, do you see we're currently in rectangular coordinates? It says you can arrow to the right here and do polar coordinates. And then when you go back and trace, it's now doing our theta stuff at the bottom, okay? Notice there's an orientation to this. Do you see how it started? If you trace around. Great fun. All right. Little exploration. Let's change the 2 out in front to a 4. Actually, I'm going to retype it because I want to see. No, maybe I won't. I'll just change it to a 4. Those of you who have colored ones. So what changes when we change it to a 4? The radius it goes out to is 4, yes? Okay. Let's change the other one. Oh, thanks. To a 3. Yes. Change the inside to 3. Now does it have 3 petals? Okay. Yeah. Change it to 4 petals inside. Uh-oh. What happened when I made it a 4 inside? It gave me 8 petals, right? The original 2 gave me 4 petals, yes? Okay. Are some of you having great fun now? I've totally lost you for the rest of the day. All right. I want to talk, Michael, this is yours. I want to talk about some other graphs. Do you think we could play around in a couple minutes? Can we, but please, I promise you'll have time to play around, but let's finish the video, not listening to you all mess around, okay? Can we do that for me? Thank you. All right. Let's do this number 1. So go back and put in 2 sine theta. What is 2 sine theta? Do a zoom square if yours is an oval. It should be a circle whose diameter is 2, right? Now, what do you notice about the symmetry of this? Where's the... Did you do zoom square? Now we good? Okay. Is this have symmetry with the y-axis right here? Or the line theta equals, it actually has a lot of symmetry because it's a circle, but there's a line clearly going through it, right? I want you to think about that. That's the y-axis, and what word does that say? Sine, right? Sine and y kind of go together, yes? All right, number 2. If we type this one in, 2 plus 2 sine theta. What? Okay, look at worksheet 10. Does anybody know what this thing is called? On worksheet 10A, it names these guys. Oh, that's badly. I went too hard. And the 1, 2, 3, 4. 1, 2, 3, 4. Okay. I drew it in the right color. It's called a cardioid because it looks like a heart, doesn't it? Here's it's this one, it's just turned, but do you see it has a little dimple? Okay. Those are all circles. The inner loop, okay, this is called a lemmason with an inner loop. The one that just has a dimple is called a cardioid. This is called a dimpled lemmason. I don't know the difference between those two. Couldn't tell you. Okay. I don't know that I've ever seen one like this, but that's just a ovally looking thing. These are the fun ones, okay? Please notice right up here what it says. It says the roses will come from A cosine B theta or A sine B theta, where B is greater than 2 then it has n petals if it's odd, and 2 n petals if you put an even number in. So when you put a 2 in, you get 4 petals, okay? If you put a 3 in, you get 3 petals. If you put a 4 in, you get 8 petals. If you put a 5 in, you get 5 petals. So odd, it doesn't double, even it does. Now, the other difference is that these two are sine, so they have Y symmetry, even the odd one here. This one has both, but cosine, the odd one here, has symmetry with the X, okay? I didn't ask a symmetry question on the quiz, so we won't spend too much time on that, all right? What about number 3? Did you do this one? One minus 3 cosine theta. It's the lima bean thing again, but it's on its side over here. What changes with the symmetry then? Let's see, it goes out to 2, right? And then out to 4. Okay, mine is not good, but something like that. This time the symmetry is with this axis, right? Because it has the word cosine. Do you see that? It makes it x-axis symmetry. All right, so when it has symmetry to the line, guys, this is symmetry to the line theta equals pi over 2, which is also known as y-axis, right? Oh, I already wrote that down there. It's called symmetry to the polar axis is x-axis symmetry, and symmetry to the pole or the origin. Do you remember origin symmetry? When you turn it 180 degrees, it still looks the same, okay? All right, there are fancy tests for these symmetry, but since I didn't put it on the quiz, I won't bother to go over them too much, okay? So that takes us to these crazy different names for them. So the cardioid is really just a fancy name for one of the lemmasons, okay? It's in the lemmason category. And we can do a spiral. Spirals are kind of tricky to put on your calculator because they spiral off your screen really fast. But it's A theta plus B. So let's try one. Let's put in 2 theta. Actually, we might mind a little number. Plus 1. I don't know. Yeah, it spiraled really big, really fast, right? Off your screen. Let's try 0.1 theta plus 1. Okay, it fits on my screen better, but how do I want it to keep going? Yeah, I need to change my max because it went around 1 rotation, right? Which is 2 pi. So I would want to change this to, I don't know. Well, yeah, I'll just put in like 50. It's going to take it a while. Okay. I can't look away. I put in 0.1 theta plus 1 with a window of 0 to 50. Okay. What do you see as the difference between these two right here? Yeah, this one goes opposite. And it says here to do that, you would just make theta negative. So if we went from like negative 50 to 0, I think it would go the other direction, but it would actually go inward too. Anyway, not worrying about it. Yeah. All right. You can also do these by hand, guys, by thinking about the symmetry. Okay, this is a sine graph. The amplitude is only a half. It finishes a cycle by pi. So then when you're graphing it on here, you have seen all the values by the time you get to pi. I'm not gonna take your calculator away, so let's just go back and do a couple for fun here. Can anybody predict ahead of time what this is going to be? Using your... I think it's a flower, isn't it? Because there's no plus or minus anywhere. Look at worksheet 10. And the 4 tells me, okay, when it's an odd number, what happens? Odd number of leaves means no doubling, right? And 4 means how long they're going to be. And sine means it's going to be symmetric to the y-axis. My question is it this one down here? Okay, so then these must be at, let's see, if it has symmetry, 60 and, no, 45 and, okay, that was really bad. I think it's this one. That's got to go out to 4 though, right? Okay, does that look at all like what it looked like on the calculator? Okay. Can anybody help me with this one? This time the petals are going to be 3 long. It's going to be symmetric to the X. Does that mean it has a petal here, guys? Okay. And the 2 gets doubled, right? So there's 4 petals. Is that what it looks like? So does that one not matter if you do sine or cosine? It's exactly the same graph. I'm just thinking ahead here. I'm questioning myself, discovering 3 cosine 2 theta. I do need to change this back to 0 to 2 pi or it's going to take a long time. So I get that. If I change to 3 sine, oh, so you're saying the symmetry, oh, why did it stop though? Oh, it's supposed to be 2 pi. See, that's a bifocal thing. I can't see that button. All right, so the cosine one looked like that, but the sine, if I do sine, then its symmetry is here. Oh, it's so pretty. All right, number 6. What kind should this be? This is a rose, yes, because there's no adding or subtracting, okay? Give me some more names. Okay, help me finish the video and then you can play. Give me some more names for this point from yesterday. Put your calculator down, look up here. Okay, that point could be called what? 150 with a negative 3, which, remember, the order is backwards of what Hofbauer thinks. Put the calculators down. What else? 330. Okay. It said they wanted an angle between 0 and 180, which is what we did here. But let's just name it a few more ways because that's what it's like on the quiz. Okay, so go negative 30 degrees, and then you would still go out positive 3. Okay, what would make it a negative negative? So if you rotated this way and then backed up, right? So that would be negative 210, is that right? All the way around to there? Okay, that's written really badly. All right, don't pick your calculator up yet. Okay, practice what we learned at the beginning of the day. 150 and 3, 1, 2, 3 is out here. Negative 245, 45 back up 2. What line is that really on? If we wanted to call that 2, what line would it be on? 45 plus 180? Thank you. So if this is really 2, 225, and this was 3, 150, if we want to do the law of cosines, what is the angle in between here? 75 degrees. So we have this triangle. Now, contrary to my picture, we can't use Pythagorean theorem, right? Because that's not a 90. Clearly looks like one, but it's not. X squared equals 3 squared plus 2 squared minus 2 that came with the formula, and then the 3 and 2 from our triangle, cosine of the difference, which is 75 degrees. Now you can touch your calculator, but please type this in. All right, I got 9.89. Is that the answer? I forgot to square root, right? I got 3.15. Is that right? You guys are all in radians. That was a great moan, because guess what you have to be able to do on the quiz? Yeah, you're going to have to know when to change back and forth on this quiz. Not necessarily. Why shouldn't I need to remind you what mode you need to be in? Okay. Yeah, something like that. All right, number 9. Oh, what happens when we put a minus in? 2 minus 2 cosine. Oh, I see I don't have this one turned on the right mode, so now I changed it to degrees and it won't work. Oh, I got a dimple. Did you get a dimple? 2, 2, and then how far over this way? 1, 2, 3, 4. Is that right? And what is that called? It really has 2 names on there. It's called a dimpled lima bean or dimpled lima side. It's also called a cardioid, right? It's just because it looks like a heart sideways. All right. I like this question. For fun, suppose she wants a rose on her stationery. Determine an equation for designing a rose with 8 petals. Each petal is 4 units long. 4. Cosine or sine, depending on the symmetry she wants. 8 petals would come from a 4 there. Is that right? Need my calculator in radians again. Guys, you can do this in degrees, but oh, I don't want to get rid of that beautiful picture I have. If you change it to degrees, you got to change the window and everything. I'm going to make this one go over the top in bold since I don't have pretty colors. Okay, it would be an 8-leaved flower thing. And changing it to sine would be okay. Yep, rose. Okay, your homework, guys, is on worksheet 7. The bookwork is on the back of 7, the actual problems, and the assignment is on the front. Hey, you have 10 minutes to work on homework. If you can play with your calculator, but if you borrowed one of my calculators, will you please put it back in function mode? Okay, and then bring me your pretty designs and show me.